And some of these I've heard recently someone talking about the decreased albedo of the Arctic Ocean is maybe increasing snowfall in the Arctic and increasing land-based albedo. And I don't know if there's a story there, but that would strike me as a pleasant surprise.
It's a pleasant surprise that is short-lived, because if you have a very warm air temperature, and we talk about area close to sea level, you might have reducing albedo for a few weeks if you increase the precipitation. It is true that we have an increase in precipitation. We see that on top of Greenland. It grows every year by 5 centimeters in height now because more moisture, warmer air has more moisture, so we increase. But you also start to get your melting season earlier. That means instead of, a good example, I usually went to Greenland in the month of May, mid-May. Now I will start in 3 weeks because Greenland area where I usually land the plane melts about 2 to 3 weeks earlier than 20 years ago. So I have to do early finals.
It is. Just to add, there is this fixation, I think, amongst climate modelers and analyzers on the positive feedbacks. But there are, what actually happens in fact is a combination of feedbacks, and there are some negative feedbacks. And there are some. The area that I'm particularly excited about is the Southern Ocean. So the Southern Ocean, is this ocean that surrounds Antarctica. It's sort of the sleeping giant in the whole climate change story. The Southern Ocean is hugely influential on the global ocean. About 50%, the properties of 50% of the global ocean are determined by what goes on in the Southern Ocean. And I won't go on too long about this, but one thing that has come out, a bit of a surprise recently, is that the winds over the Southern Ocean have been intensifying. Okay, we know this from observations. And this has a consequence on the global carbon cycle. There was a paper in Science a few months ago, 2 papers, one in Science and one by me in geophysical research letters, that showed that the consequence of this speed up of the winds is a change in the circulation of the Southern Ocean, such that there's been an uptake of carbon, old ancient carbon, in the abyss to the surface that has been outgassed. And so that's a bad feedback, that's a positive feedback. We don't like to see that. What we've also discovered though, and this was debated recently through technical notes in Science just a few weeks ago, is that what we've been able to predict is that this has shut down this positive feedback via a mechanism. I won't get into the details, but this positive feedback has now done a flip-flop. So the system has kind of healed itself. So a situation that looked kind of dire now has turned in the opposite direction. And there's another negative feedback in the same realm, and that concerns the fact that these intensified winds have been causing sea salt to be entrained into the atmosphere. The amount of sea salt that gets into the atmosphere goes like the cube of the speed of the wind. Okay, and so this is a very powerful effect. And it is just being determined now with recent ice cores on the Antarctic Peninsula that we've seen in the last 100 years a clear buildup of sea salt via this mechanism. The more sea salt you have in the atmosphere, the more reflection of solar radiation you have. And this is a negative feedback and a good story. And so, it is important to bear in mind that there are, what you see in fact is a combination of positive and negative feedbacks. And sometimes these combinations are complicated in themselves.
I would like to add another positive feedback which should shut down the whole warming. If we actually decrease the sea ice extent, no more sea ice is formed, and sea ice pushes heavy water out that actually sinks, which is one of the main drivers for the heat engine for the Earth, the conveyor belt. And the Heron-Thurline circulation. We know that if there is too much fresh water, we cannot produce so much with the models or with the prediction, but if you melt too much of Greenland or Antarctica, you reduce that heat engine, and that cools down the Earth very fast. And we know that part, and I mentioned that this morning, that in the ice cores we have climate history, very accurate by an annual resolution. Within the last 100,000 or 200,000 years, we had about 8 abrupt climate changes where we measure a temperature change between a warm, pleasant climate like today and an ice age within 5 to 8 years. And the only way to explain it is if you shut down this conveyor belt, and that is probably occurring in Antarctica when some of these ice shelf water are now circulating. So you have very strong breaks in the climate system. But we don't want to get a break either, because then we go into a different climate system.